My name is Mira Wellner, and my research is on using autoencoders to decompose hyperspectral images into their three primary component materials. So a hyperspectral image is an image where, rather than having the distribution of the colors red, blue, and green in the image, like a standard image, it has a distribution of a large number of very narrow hyperspectral bands. The dataset we used had 31 such bands. And hyperspectral images are incredibly useful in figuring out the chemical processes of various scenes and images. The objective of this project is to use an autoencoder to compress and decompress a hyperspectral image and use the compressed information to find the three primary materials in the hyperspectral image. The reason why this is able to work is because of some past research done that indicates that the vast majority of images and scenes in the Earth have three primary component materials and two light sources. And if not, they can be fairly accurately represented by three materials and two light sources. For this initial study, we didn't use light sources, but we assumed that each of the hyperspectral images had three primary materials. So that's three spectra. And what we did was we fed it through an autoencoder. Now, most autoencoders, they simply use convolutional layers to compress the image into latent features and more convolutional layers to decompress it. But what this particular autoencoder did was, for the decoder, it implemented the above equation, and it split it into its material maps and spectra. And what this did was, because we were reconstructing the latent features, assuming that they were hyperspectral image spectra and material maps, that meant that they became that. And once that happened, we ran it for 25 epochs, and we got a very low validation loss. As you can see, the accuracy of the spectra is much, much higher than the accuracy of the material maps. That's likely because the spectra were selected for rather than the material maps. But certainly work needs to be done to improve the accuracy of the material maps. So the trained model was then split into an encoder and a decoder, and an image of some wood, like a wooden floor, was run through the encoder, and it got these three spectra. Now, the spectra that it yielded don't represent anything that, we as amateurs could instantly recognize as being part of wood. There was none of this is carbon or water. However, we definitely need to do further research with domain experts to see if this would indicate something that could be found in wood. And obviously, the hundreds of other images, see if there's, reasonable accuracy in that too. Thank you.